Hello and welcome back to Calero Academy. Today we'll be doing another version of the question 13 from the diagnostic test from the online school Art of Problem Solving. The question states, find all theta being between 0 and 2 pi, such that sine theta plus cos theta all squared is equal to 3 on 2. So, I'm going to divide this pseudo-proof into two parts. In the first part, sine theta plus cos theta will be more than or equal to 0. Or, to say it in another way, that sine theta plus cos theta is equal to the root of 3 on 2, the positive root. Case 1. In this case, we have, expanding this equation, that sine squared theta plus 2 sine theta times cos theta plus cos squared theta is equal to 3 on 2. However, 1 is equal to sine squared theta plus cos squared theta, and sine of 2 theta is equal to 2 sine theta times cos theta. So we can rewrite as 1 plus sine of 2 theta is equal to 3 on 2. And that therefore, sine of 2 theta is equal to 1/2. Okay, now, what we do now is we decide what sine of what angle is equal to 1/2. If we remember equilateral triangles, we can remember that sine of 30 degrees is equal to 1/2. And that therefore 2 theta is equal to 30 degrees, and that theta is equal to 15 degrees. But that's not the only value of theta. We have to watch out that we don't forget other thetas. Sine of any angle alpha is equal to sine of 180 degrees minus alpha. So in this case, we have alpha over there being 30 degrees, and alpha over here being 2 theta. So we can rewrite that alpha, 30 degrees, is equal to 180 degrees minus 2 theta, or that theta is equal to also 75 degrees. So we've discovered 2 values of theta, and I can tell you for free there's 2 more. Let's go into case 2. Case 2. In case 2, we're going to have that sine theta plus cos theta is less than 0. Or, to put it another way, that sine theta plus cos theta is equal to the negative root of 3 on 2. Now, after this, we get this after taking the negative square root of this equation. So, after some rearranging, we see that minus sine theta minus cos of theta is equal to the root of 3 on 2. But wait a second, that's just equal to, from over here, sine theta plus cos theta. Now, how can we explain that minus sine theta minus cos theta is equal to sine of theta plus cos of theta? If we answer this correctly, we can find the other 2 values of theta. Now, we're going to have to divide case 2 into 4 different mini cases. This is because we want to make sure there's not an infinite amount of cases, 10 cases or 8 cases, but 4. So we're going to be mathematically rigorous and try to sniff out all the thetas out of their holes and make sure we're not leaving any behind. No angles left behind. So, the first mini case A of case 2 says we use the easy identity that cos of theta is equal to minus cos of 180 degrees plus theta. And that's the same thing is true for sine. Sine of theta is also equal to minus sine of 180 degrees plus theta. If we substitute this into here, minus cos of 180 degrees plus theta into here, we get that sine of 180 degrees plus theta plus cos of 180 degrees plus theta is equal to sine theta plus cos theta, or simply that theta is equal to 180 degrees plus theta. Therefore, the two other values of theta, 75 degrees plus 180 degrees and 15 degrees plus 180 degrees, here and here. So, theta is equal to 15 degrees, 75 degrees, 180 plus 15 degrees, 195 degrees, and 75 plus 180 degrees, 255 degrees. Now, we're going to do 3 more cases to make sure there's no other thetas. So, case B. Suppose the answer is not so simplistic that we can't just leverage such an easy identity over here. So, let's say that cos theta plus sine theta is equal to minus cos of phi minus sine of phi for some weird phi, where phi is not equal to 180 degrees plus theta. So, maybe instead, let's reorganize this, that cos of theta, is equal to minus cos of phi plus x, and say sine of theta is equal to minus sine of phi minus x for some value, for some integer, for something x, for some arbitrary x. Next, let's try to get rid of the x's and equate these two equations. What we do, we add cos phi to both sides over here, and we add x to both sides and minus sine theta to both sides. So we get that cos theta plus cos of phi is equal to x, which is also equal to minus outside of sine theta plus sine of phi. Okay, now, what we do now, we try to get the thetas and the phi's on one side each. So we rewrite it as sine theta plus cos theta is equal to minus outside of cos phi plus sine phi. Just rearranging the equation, nothing's going wrong. Now we square both sides, and we use the fact that sine squared alpha plus cos squared alpha is equal to 1 for all alpha. We get that sine squared theta plus 2 sine theta times cos theta plus cos squared theta is equal to sine squared phi plus 2 sine phi times cos phi plus cos squared phi. But since we know that sine squared plus cos squared is equal to 1, we can subtract 1 from both sides, and we get that 2 sine theta times cos theta, which is equal to sine of 2 theta, is equal to 2 sine phi times cos phi, which is equal to sine of 2 phi. Now, this means either that theta is equal to phi, which would mean we already proved that, and that means there's no more other thetas for this case, or that 2 theta is equal to 180 minus 2 phi from the equation over here. But that too would not be distinct, because that is how we got 75 degrees. So that means in case B there are no other thetas. So now, moving forward, a case C. Case C. Suppose, let's try another more careful answer. Let's have the same thing as before. Cos theta plus sine theta is equal to minus cos phi minus sine phi. And now let's organize it so that we have that cos theta is equal to minus sine phi, and that sine of theta is equal to minus cos of phi. Same thing as this equation over here. We're just if we add them together, we get this equation over here. But if we work through this too, we find that it's not distinct either. If all we have to do now is just add and square. We add sine theta to both. We add this equation to that equation, and we get that sine theta plus cos theta is equal to minus outside of sine phi plus cos of phi. If we square it and do the same thing we did over in part B, we get the same thing. Phi is not distinct from theta. So, final case, our last try, our last chance to smoke the thetas out of its hole. Last try. D. The last case. Let's have cos theta be equal to minus sine of phi plus x, and that sine of theta is equal to minus cos of phi minus x. Same thing, you add it, you get the equation, you get this equation over here. Nothing's changed. But if all we have to do now is just equate, and again, look what happens. We have, getting x's together, we get that sine phi plus cos of theta is equal to x, which is equal to, on this side, minus cos of phi minus sine of theta. Or that sine of theta plus cos of theta is equal to minus outside of sine of phi plus cos of phi. This is the same thing as before. If we square both sides, we're going to get that phi is not distinct from theta. Therefore, we've reached the conclusion that all theta between 0 and 2 pi radians that satisfy the equation that sine theta plus cos theta all squared is equal to 3 on 2 is equal to only these four numbers: 15 degrees, 75 degrees, 195 degrees, and 255 degrees, or in radians, that theta is equal to pi on 12 radians, 5 pi on 12 radians, 13 pi on 12 radians, and finally 17 pi on 12 radians. This means we've found all the values of theta and we've answered the questions. Thank you. This has been a Calero Academy production, and thank you for watching. In addition, Calero Academy will now start taking questions in the comment sections on the videos. So if you have a question that you want us to solve, make sure you get copyright permission, and then plant it onto the comment section and we'll do a video for you. Thank you.